Okay, in this video we're going to discuss quadratics, which are basically parabolas or anything to the second degree. And I'm going to present a bunch of examples in the main three forms: vertex form, standard form, and factored form or intercept form. And basically we're just going to find the vertices in each one. And as we do that, kind of discuss the properties and techniques and the way these are all interrelated to each other. So looking at the first examples, we have vertex form, which is the easiest way to find a vertex because, note it's in vertex form because it reveals the vertex, which is hk. And the most important thing to remember in this is that the h, it's minus h and plus k. So let's take a look at our first example. We have y equals 2, which is the a value, which shows the stretch, times x minus 4 squared plus 6. And again, if we just pull out the h and the k, we recognize that h is 4. And remember, it's not negative 4, it's 4. And the k is 6. Therefore, the vertex for the first example is 4, 6. And if you wanted to check your work, you could probably quickly do a sketch. You basically just draw an x and a y. And if 4, 6 is here, the y-intercept would be plugging in 0. You would get 0 minus 4 is 16, 32, 38. So it's way up here. And our axis of symmetry would be x equals 4 because that's where the vertex is. Vertex always lies on the axis of symmetry. So if this is 0, what did we say it was? 16, 38. Then if we were to plug in 8, we'd get 838. And we'd have a parabola that looks something like that. Now, looking at the second example, we have negative x plus 5 squared plus 2. This negative, again, it mentions how much the parabola is going to look in terms of an up and down stretch, or in this case, if it gets reflected down. So this is actually going to face down. And again, we look at our h and our k because this is in vertex form. And our h value is, again, it's not 5. This is really x minus negative 5. So our h value, our axis of symmetry is going to be at negative 5, and our k value is going to be 2. So in our second example, our vertex is negative 5, 2. And again, you can graph it or plot some points to verify your answer, but those are our first two examples. Okay, the next pair of examples we have are in standard form, quadratics, and that is ax squared plus bx plus c. And a is the coefficient, the lead coefficient, in front of the quadratic term x squared. And then b is in front of the linear term x, and c is the constant. And of course, we have our negative b over 2a. Perhaps some of you are familiar with that formula, and that determines how you find the axis of symmetry. And of course, once you find the axis of symmetry, you can find the vertex because it always lies on the axis of symmetry. So let's take a look at these two examples and we'll just use the formula. So the first one is x squared plus 10x plus 7. And by the way, what is the y-intercept for you linear equation people? It's simply plug in 0 and it's 7. So this actually intercepts at 7, just a side note. But going back to our question at hand, let's first write negative b over 2a, and the a term is equal to 1 and the b term is equal to 10. Therefore, the axis of symmetry is negative 10 over 2 times 1, which is equal to negative 5. And of course, if the axis of symmetry is negative 5, the vertex lies on negative 5. So we plug negative 5 in and we get 25 minus 50 plus 7, which is negative 18. So again, this is negative 5 squared is 25. Negative 5 times 10 is negative 50. And plus 7, these add up to negative 18. And therefore, our parabola has a vertex at negative 5, negative 18. So let's look at the second example. Same thing. You have negative b over 2a, and it's equal to, the a value is negative 3 in this case, and the b value is equal to 5. Therefore, the axis of symmetry will be negative 5 over 2 times negative 3, which is equal to 5, 6. And if that's the axis of symmetry, our vertex is 5, 6 something. And so now we got to play with some fractions and plug it in. 5, 6 squared is 25 over 36. So that's going to be 25 over 36 times negative 3. And then plus 5 times 5, 6 is 25 over 6. And lastly, we have plus 2. And now again, we have to add this up to get our fractions. So let's use common denominator. This is negative 75 over 36 plus 150 over 36 plus 72 over 36. Oh my gosh. But we're still in this. Not as bad as it looks. So we have negative 75 and 72 is negative 3. This is 147, oh my gosh, over 36. And I'm not sure if that reduces. Actually, we'll just leave it for some other time. But nevertheless, you can check it online. Again, negative b over 2a, negative 5 over 2 times negative 3 is negative 6, 5, 6. Plug 5, 6 into our equation, and we get this whole mess. And we add that all up, and we end up with our y term, and that is our vertex. Okay, before moving on to the third batch of examples, I wanted to take a quick, go off on a quick tangent and look at completing the square, because I think it's interesting and related to finding the vertex and quadratics. And I want to quickly write out the quadratic formula, which you might recall is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you recall this is b squared minus 4ac is the discriminant. And if you cut out this part, we have negative b over 2a, which you just saw in the previous two examples is how you find the axis of symmetry. So I thought it was interesting to see how they're related. And then look at these two examples that are in standard form. And what I'm going to do is I'm going to convert them to vertex form and use completing the square. So let's take a look at the first example. Y equals x squared minus 6x plus 8. And if you recall from completing the square, I like to take the x's by themselves. So x squared minus 6x, and put the 8 over here. Then what I like to do is take the x term, divide it by 2 and square it, sort of like this, negative b over 2a. So divide this by 2, which is negative 3, and square it, plus 9. And of course, since we added 9 over here, we want to keep the equation balanced, so we're going to subtract 9. So we've we've added 0. And then now we're going to factor. This is x minus 3 times x minus 3, which is x minus 3 squared, minus 1. And we have a quadratic in vertex form. And what is the vertex? As you remember, it's negative. Here's the h value, which is positive 3, and k is negative 1. So 3, negative 1 is the vertex. And of course, we could quickly check that. If we were to take negative b over 2a, we would say negative 6 over 2 is negative 3. I'm sorry, it's negative 6. So it's positive 6 over 2, which is positive 3. And if we plug 3 in, we get 9 minus 18 is negative 9 plus 8 is negative 1, and we get the same answer. So it's another way of recognizing how everything is interrelated. Let's take a look at this next example. I wanted to show this one because if you notice, the coefficient of the first term is not 1. And so completing the square is a little bit different. So again, what I'm going to do is I'm going to separate the x's. Put the negative 1 over here. And since the coefficient is not 1, I'm going to make it 1. So let's factor out 3. And we get 3 times x squared plus 2x. And still the minus 1's over here. So we factor the 3 out. And now let's complete the square inside the parentheses. And what we're going to do is we're going to add half of 2 is 1. 1 squared is 1. And again, we always want to keep it balanced. So what did we add on the right side? We added a 1 times 3. So we need to Since we added 3, we need to subtract 3 over here. And then now let's factor the inside of the parentheses, which is x plus 1 times x plus 1, which is x plus 1 squared, minus 4. So we have y equals 3 times x plus 1 squared minus 4. And what's our vertex? It's hk, which is -1, -4. And again, if we were to use our other format, negative b over 2a, we would get -6 over 6, which is -1. We'd plug -1 in, and we would get -1 squared is 1, times 3 is 3, minus 6 is -3, -4, and it lines up. And here are 2 examples of quadratics that are in factored form. Here's 1x, 1x. If you were to multiply this all out, you would get an x squared value, which is a quadratic. And these p's and q's are the zeros. So if you were to plug in p or plug in q, you would get a 0, which of course would equal 0, and it would be the x-intercepts. This first question I actually saw a couple weeks online. I watched 3 people in the chat room try to figure out what the vertex is, and I was kind of surprised because their approach was multiply the whole thing out, use negative b over 2a, etc., etc. There's a much more direct way, and what it is recognizing what's going on here. If you were to graph this, where would be the x-intercepts? Well, they would be at 1, 0, because if you plugged in 1, you'd get 0. So this is 1, 0, and they would be at 5, 0. Okay. By the way, where is the y-intercept? Well, the y-intercept is somewhere here, so if you plug in 0, you get 0 minus 1 times minus 5. 0, 5 is the y-intercept. So our parabola is going to look something like this. So what's the vertex? Well, looking at it from this standpoint, I don't need to complete the square. I don't need to use negative b over 2a. I simply have to say, look, this is always going to be symmetrical. So it's going right down the middle. This is the midpoint of these 2 points. So the midpoint of 1 and 5 is 3. This axis of symmetry is 3. Therefore, the vertex is 3. And what's the point? Well, you just plug it in. If I plug in 3, I get 3 minus 1 is 2, times -2 is -4. So that's our vertex. I basically find the midpoint, which determines the axis of symmetry between these 2 points, and then solve from there. Okay, so then we look at the next example. Same thing, except you just need to recognize that this is the same thing as 4 times, which again, this is our a value, 4 times. X is like x minus 0, and x plus 8. So what are our zeros? Our zeros are p and q, which is 0. So if we were to look at it, a graph, we'd have 0. And again, it's x minus q, so it'd be -8, 0. And what's the midpoint of 0 and -8? It's -4. Our axis of symmetry. This faces up, by the way, so it should look something like this. And if we plug in -4, we get 4 times -4 is -16 times +4 is -64, way down there, so I guess I should have drawn steeper. But anyway, that's the answer. There's your vertex. Again, finding the midpoint between 2 points that are on the same y, and simply find the midpoint, get to your axis of symmetry, plug that in to find your vertex, and there you have your point. So I hope this was helpful. If not, check out some sites and look at some examples of quadratics and try to find the vertices and practice on your own.